It has gone live. Is it actually live on YouTube? I do not know if it's actually live on YouTube. It appears to be live on YouTube. I am hoping it is live on YouTube. YouTube can be so finicky sometimes. Okay, so here we are. Is there a way to... I'll go ahead and blast this out real quick. Let's see. How do I click post? There I go. There we go. At least one of those, and I will blast it out to the twits. Come on, Twitter. At you go, Twitter. Come on. There we go. Yeah, I should have done this like way before, but nope. There we go. Alright, so now I've twitted it and I've faced the book, and now I will switch on over to my Mesen window, and hopefully, let's see, yep, everything seems to be going okay. So this is going to be a little bit different than my usual streaming content, just simply because I want to do something different. What we have here is a fairly famous game for all those people, all of those of you who have grown up in the NES days. You'll remember this game, I'm sure. It is Megaman 2. I'm going to do a series at some point on this game, and the idea is I'm going to basically go through all the quirks and interesting things that I've found in the code, and part of doing this is something I've been doing for the greater part of a year when I have time to sit down and actually like go through the ROM itself and the code that the game actually runs and figure out what everything is doing in the code. And it's been a journey. There's a lot of stuff that is part of this. I'll just go ahead and switch over to the debugger view here. You can see that there's I've already done a lot, and you know, there's a ton of labels over here that I've already set up. So there's that, and functions and everything. The program that I'm using, the emulator, is Mesen, and quite honestly, it's probably one of the best emulators I've encountered for this kind of stuff. So here you can see I've got a couple of different ways of looking at things, and I'll try to switch these around as things go in order to give you a better view of what's going on. I need let's see. Yeah, that's not what I want. I'm trying to figure out how to... Okay, I can just like drag this window down. I'm trying to figure out kind of how I want things so I can get kind of the important stuff on the screen while still having, because doing this occupies a lot of screen space. So we got the memory window. PPU viewer, so I can view the name tables, all the characters. It's interesting how things work here because a lot of these come in as blocks. It's fairly interesting. Also sprites, so I can view sprites as they come in. And I've got a view down here that shows you all the various windows. Probably leave it on. Sprite viewer is probably the more interesting one for now. I've got two memory views, but I'm only really going to be showing you the primary memory view. Sometimes I'll be looking at things and I'll need two different viewports in order to, because one of them might be a table of pointers and the other one I'm using to look at the memory that's being pointed to by that table of pointers. So that's kind of basic workflow. And this shows the full debugger, so you can see all the watch, breakpoint, call stack, labeling stuff and everything. And this is probably what I'll primarily be using for debugging, which shows mostly the debugger, the memory, and of course gameplay. And then if I need to, I can always go back to this view which shows everything. Let's see. Let me check on stream. Yeah, there's not much going on right now. There's just me. Hopefully there'll be more people as things go on. So now that I've kind of said my piece about, oh, this is what I'm doing and all, yeah, let's start where I last left off. So right now we're in the Pico Pico Coon boss, and I can see that the state handler is pointing to wake block. I don't think I've actually stepped into wake block yet. Yeah, because it's green and pink. So pink is, it doesn't know whether it's data or code. Green is, it knows it's code, but we haven't been there yet. If it's got a white background, we've been there, so obviously. So this is the part where one of the blocks will wake up and start attacking. So we'll go here. And I can see that it's 9242. Oh, that's interesting. Okay, so it's going to decrement that, and if it's not 0 yet, then it's going to wait. And my labeling convention is usually, because there's a lot of repeat labels that happen, is to add the ROM address to the label, and then I will call this one. So the way this works is these routines run every frame, and so you'll do things like you'll have a wait routine like this where it's decrementing something and then it's waiting until it reaches 0. Once it reaches 0, then I will probably disable that breakpoint and come back up. Let's see. Here, make sure that I have, okay, I do have that disabled, so I'll run the game for a moment. And I'll go ahead and disable this until re-reach. I'm wondering if maybe this is not wake block, but something else. So now that it's done waiting, it's going to change the state to that again. And it's going to call that, and then go back to this thing where it's going to stop doing, I think. We haven't changed the boss state yet, so we're still in the wake block state. Why is it an animate gate? Oh. Oh. So this works for both gate and this boss that has an animated animations on the name table. So I will which means I must have missed something. Okay, that's the main gate loop. I must have missed something that... let's see what happens here. So we'll step, and it's gonna branch to this, and then we're going to... Looks like we're doing some... okay, we're going to pull the addresses, and then we're going to start. So I'm going to change the viewport to include the PPU viewer, so you can watch what happens on the name table live here, because we're going to start copying data to the name table, which name table is background data. So you'll see in the active name table is the right hand name table right here. You can see this block right here has changed. That's the open block. So then we go there and CD249. So that is going to do the next byte. Again, this is another one of those labels that is prolific throughout the code. It just is. So then we'll start. So we had 2 bytes that we wrote. You can see they wrote just like that. It's interesting. PPU is in vertical right now, so it's actually writing vertically down instead of across. Looks like we've got an outer loop here, right? 264. No. So this is going to 264. I think that's going to be done. Okay, so now we will load more 239. Just call this next block. It's really just a pair of tiles, but we'll just call it next block. And we jump up. And we do it all again. This will be the next 2 tiles here. And you'll see as it stores, there it goes. And then we got one more. And that stores. And now we're back here. Now it's going to go to 264, which is so it has loaded all 4 parts of the block. We're going to decrement 231. Oh boy. I think I'll call this next column. And it's very fluid because when it's the first time I'm going through code, I don't know what it's doing. I have an idea, I have an educated guess, but I don't actually know what it's doing until I see what it's doing. So then we're going to go to another block here, and we'll address, and you'll see some of these labels look wrong, but trust me, they're right mostly. It's just that in this case, it has pointers that go off of different references, and sometimes they reuse areas of memory. They'll use it for one thing in one moment, and I try to pick the most common use as the name for the memory labels. So now we're doing this. And what are we changing here? What's the address? 2544. Which 257B? Where's 2544? 58624 425. Two 251B 2524 2544. What's it doing well on that side? Huh. Okay, so right, because I forgot they actually come together as two separate. See, I've missed something that it actually loaded to the PPU. I blew right through something, unfortunately. So I'm seeing the back end of this. This is in the NMI, which is the routine that basically the way this game works is it takes all this data and puts it into a buffer. And then it goes through this NMI routine, which actually talks to the PPU during vertical blanking, because you can't do this stuff while it's drawing on the screen. There's a conflict when it's trying to read and write memory at the same time. And things will break. Things will, it'll cause the PPU to act badly, and then you get all sorts of weird artifacts and stuff on the screen. I do not think the PPU has dual-ported memory, which would not cause those artifacts. So it has to write when it's not actually updating the screen. So all this happens in vertical blank. And let's see. So we'll go to the next column of this block, and we'll write those two tiles in, and now we're done. So we'll store the flag. We will reset the PPU control flags. The control flags were set for vertical writes. And now we will finish this up and see what happens. Okay, we're back in wake block. You see right here, I think that's probably where I wanted to set a breakpoint that I didn't set, because all of this now is run, and I'm pretty sure that's what wrote out the data to change the appearance of those two blocks. So I believe it's going to do a wait again. So I can go ahead and disable that breakpoint temporarily until, okay. So now we can see those two are coming together. We're back here. Okay. So we're going to look for a boss object. Carry is clear, so we're going to go back up to wait. And this is checking, I think, So this, okay. So find boss object. So it's looking for the sprite object, and it's found the sprite object. So it's those blocks are running their own routine. It will wait because carry is clear. Okay, so I'm going to set this breakpoint, and I'm going to clear out. I just cleared out one of the options on one of the buttons on the input buttons. I've got my game controller here, so I can actually do this like a real game. I'll pause the game because I want to go to Metal Blade. Okay, so now I've destroyed that one. Another block is going to come after me. And playing the game through like this with breakpoints and debuggers and stuff is always rather interesting. So let's see. Bring this up in the memory viewer here. So this is the memory viewer window, and we have 92DD, which is here. The X right now is 1, so it's going to load that value into Y, and then it's going to do 933F indexed on Y. So let's see, attack timer, I think in this case is being used as a counter into which pairs of blocks are going to come to life. So let's see, 92DD is going to be, it's actually 92DE. Okay, so we've got X set to 1. Okay. Then we've got 933F, which is the next address that's going to look at. And we're pointing at 0 on this one, so let's see where this one goes. 0. Okay, so we're going to load another 0. We're going to store that in one of our address locations. And we're going to go to the next. This will be a 92, so this is next. And you see I'm not labeling these two values over here right away because I still don't quite know what their purpose is. I have an educated guess, but I don't know yet. So, okay, so now we're going to load that up, and so now I've got address 1, low and high is 0. Oh, that comment just starts at F0. I don't know. Wait a minute. No. Let's see. There must be something else going on with that. I don't know. So now we're moving to the next. And it's counting up X and comparing it to 8. So Y can vary. Yeah, right. Okay. So you can kind of see that it's changing the coloration of all those memory. So this is very weird because we're writing values. We're overwriting this area of memory here that's normally, oops. Yeah, this memory here, address 1 and on, is normally a bunch of different variables. So this thing is using these variables in a way that normally, I don't know why I've got, all sorts of different comments here. I didn't remember setting those comments, but they're doing all sorts of, they've basically overwritten this whole area, which is a bunch of different stuff that is used by other things. So they're just reusing that area, and it's making things a little bit confusing. Let's see. Then we go to the next. Whoops. Go to the next byte here. So now we're multiplying by 2. And we're going to put that in variable 2. And as our own variable 3. Okay, so init bus projectile, that really needs to be changed to bus object, because it is actually an object. Okay, so basically what that did there is that is going to bring up a sprite object. And let's see, what's this? So this is going to bring whatever was in variable 2, which was stored up there, into X. Okay, so I'm betting that this is probably locations for these blocks. Oops. Go to... So the first pair was Y. Is that the Y? That might be the Y coordinate, we'll see. Yes, that's the Y. And I don't think you can actually see me typing the labels in. Trust me, I'm typing the labels in because that window doesn't actually show. So that's pico block Y, pico block X. So then that puts it in the Y, that puts it in the X. And this is... That's the starting state, so it knows what state the object is in. And do they actually start in any other state but 0? I see some of them later on are 0, 1, 2, 3. Okay. Okay, so now this is that weird series of 6 bytes, I think. Okay, this is velocity. X and Y velocity, attributes, object lifetime. Okay, so we go up 1. I'll go to the next object. And we do the same thing again. Go ahead and initialize all these object properties, and we're at 2, so now we're going to look at, I think attack timer is which of these little dudes, how many of them have been spawned. So address 3 is another variable. And we're going to put the object X in there. The object Y there. Okay, so calculate gate tile address. So that's going to actually figure out where Okay, so that's the X and Y of that. Of that block, where that block came from. And I think there's probably two of them that it has to do this with. So gate tile address is these tile, because it draws the gate in the background, it's also doing this in the background. And I probably need to rename this function, but I'm not going to do that right now. So we've got the gate animation flag, and it's not 0, so we're going to continue. 92CE is when we're done. Okay, so we're going to punch that up one. We're going to go to the next address, and then 92A3, 92AE, I can't read right, which is going to be next. I'll say tile. I know these are tiles. So then we'll grab the X and the Y, and then we'll do it again, calculating the address. This time we are not 0, so we're going to go to 92CE. Just going to put 82 into the animation flag, and it's going to increase that, and if it's not E, then we're done. So we will call this I will just call this Pico block tiles ready. I don't know, seems to be make as much sense as anything else. So now we're going to bring about our next set of blocks. And we're looking at that flag, and it's negative flag, which is telling us this Pico Pico Kun block that we need to do. So then that will set that up, and then we get hit. Yeah, it's a special kind of challenge to do that. So then look at this, and we load up the Y value 92DD. I am still curious as to what this actually means. So look at it. We got 0, 0, 0, 0, 0, 0. The next one 0, 8, 1, 0. I feel as if 1, 0, 0, 8, 0, 0, 1, 0, 1, 0, 0, 0, 1, 0. So that loads into Y, which we've done. Y is 0 again. And then this loads into X, or I'm sorry, into A. If I look at this in the memory viewer. Okay, so that is an offset into this piece, which is a bunch of block data. Okay, so this first one here is Pico block data offset table. I don't know why I copied that. We have Pico block data. And so it's every 8 bytes for Pico block data. Then our X and Y is stored in separate tables, as well as the starting state. And then this is where those 8 bytes are used here. So I got 1, 2, 3, 4 of those 8 bytes. And then we have that's player. There's 8 bytes being loaded. Is it only... Wait, is it 8 or is it 4? No, that's 8. Okay, there's 8 bytes, but oh, we're not using 8 bytes. Address 1, address... Oh, wait. Okay, there's 2 sets of 4 bytes. Okay. I see. So the next time it comes around, X will be 1. Okay, so it's 2 sets of 4 bytes for each of the sides of that Pico block. If that makes sense. Okay, that does make sense to me. Okay, so I am right about that being block data. So that's where sprite data for that block, or object data for that block. It's actually object data. So there's a big table in memory right around here. Yep. So each of these 32 bytes worth, so there can be 32 objects that the game controls at once. The first 16 are player, and so this is player, this is boss, this is player projectiles all the way out to here. The next 16 are essentially any enemies or other sprite type objects that are on the screen. And you've got a bunch of different values here. X, Y, actually keeps track of X and Y at the subpixel, which helps to make motion smoother. And then of course you've got, in some cases it's got an H, a high value, so it'll be a 16 plus subpixel. And then you've got all the music data down here, and then beyond that we've got more. This is mostly stuff that controls the animation of the objects, like a velocity, frame timers, frames, some hitbox. There's a section of memory that stores a bunch of hitbox stuff. So yeah, there's a lot of it. This is so discombobulating the way they do this here. So it's got that data. So I've got that. I think I've got all that mapped out. The only thing that happens now is boss state gets put to 3. So we'll set a breakpoint here. We're going to go ahead and undo this breakpoint. So I assume that once I hit go, aside from the name table rights, I'll be actually fighting the boss to the end. And I might have to undo that. I'm probably going to undo the NMI breakpoint as well, because that's going to get in my way attempting to fight these bosses. Yeah, same thing there. Yep. So until we're done. Oh. Well, that sucked. Okay, well, let's use an energy tank. And yes, I did just run the game in reverse to cheat. I don't care. Oops, not the right metal bind. I'm more under the goal of... Okay. So now we've defeated the boss, so it's going to increment the boss state. And go into here, run boss AI. And let's see, actually... No, it's not a function. Pico Coon handler. And I'll go ahead and re-enable this breakpoint here. Okay, so we're not at the boss is defeated yet. I believe. Just want to double check. 9357. Yes. So this state is defeated. And FF is stop all music. And sound. We're not quite there yet. So it hasn't completely lowered the health to 0. So we're not quite there yet. So we're gonna come back from this. And I'm gonna go do it just in case. Is it actually... Okay, so disable that breakpoint. I'm going to rename this. To last block. And I'm going to run that to this breakpoint here. I'm going to disable this breakpoint and enable this breakpoint because I've got to fight off this last pico block. Okay. One of those must be speed, that ever increasing value. I think it was like object state is the speed that that little block runs at, because they get faster as they create more. So yes, if you're ever suspecting that the Pico Coon boss actually has a set pattern that the blocks come to life in, it does. It absolutely does. So then we are done. So we're going to stop all the music. And we're going to do the whole boss defeat thing. We're not in that Wily stage yet. And yes, I misspelled Wily. And no, I don't care. But, yeah. I think I'm going to stop here because this is about all I can handle for streaming. I'm starting to get a little bit fatigued. So, yeah, that's all I have. So, I hope you've enjoyed it. A little bit different to see how going through code is. I thought it might be kind of a maybe an interesting live stream for a couple of people. Anyway, that's all I have. Thanks for watching.